Okay, so in the last video we talked through the design of this phi latch that we're going to use to build a single phase edge triggered D flip-flop. Okay, and this was the circuit I think we arrived at as of the end of last time, and I think I have one problem here. This should be D, and this one should be D bar. Okay, so what we're going to talk about in this segment is how to think about making this into a layout-driven schematic for the purposes of planning the layout of the cell. Okay, so right away we can make some observations here. One is that we're probably going to want to think about having the D and D bar inputs come in from, let's say, the left-hand side of the cell, and the Q and the Q bar outputs go out to the right side of the cell, because that's kind of the way that the signal flows through if we think about cascading these things together to make a shift register, right? So the D inputs come in from one side, and then D propagates to Q, and Q becomes the input to the D stage of the next, or the D inputs of the next stage. And so as we've laid the schematic out at this point, the D inputs are coming in from both sides, and the Q outputs are going to both sides. And so we'd like to try to, maybe the first thing to do is to try to rearrange some of those things. And the first part is pretty trivial, because all we have to do to make the Q bar go to the other side is maybe take this and simply make Q bar come out here. Okay, so that's one thing we can do. Now, here we have a D bar input and a D bar input here, a D input and a D input, and we'd like those to come in from the left-hand side. Okay, so the next thing we might consider doing is to maybe kind of unfold like this so that they're oriented horizontally, and to kind of bring these over and put them kind of in parallel with the first two. Okay, so we're gonna take this and bend it. Maybe bend it around like so. And then we can take this down here and move that over here underneath these guys. Okay, so if we take this piece from over here, can then bring this over here. Now we have the two clock transistors lined up underneath each other, which is kind of a nice thing. And actually, I can then move this ground tie point down and share a single ground connection here. Okay, so these are going to be clock inputs, and this will be, say, D bar coming in from the side, and D coming in from the left-hand side. Okay, so that's some progress. And now we would like to do something about the D transistors up here, and obviously we could do a similar kind of thing. That is to kind of bend this D transistor maybe down this way and move this one over in a position above that first one. Okay, that way all the D inputs are localized over here on the left-hand side of the cell. and we started to kind of arrange these transistors as they might be in a standard cell type layout, where you have these diffusions kind of going this way parallel to the power rail distributions, and the poly gates kind of going up like this. Okay, so let's first move the D transistor. And we can move that to be lined up here. And then the D bar transistor, I'm going to make the VDD connection once I've got the D bar transistor over there too. And we've got our VDD connection here. Okay, so that seems like some good stuff. We've got all the D inputs coming in from the left-hand side. The Q and the Q bar outputs are available on the right-hand side. And presumably we could line up the Q bar where it has to go in to feed into the D bar of the next stage, and also fork that down here. Now we have this clock strip of poly we could imagine going up here. And it would be nice if these two transistors could somehow be vertically aligned with these two clock transistors here. So now how might we think about doing something like that? Well, we have here a common drain connection between, let's say, this clock transistor and this one here. Okay, and then there's a VDD connection. So I mean, probably what we would like to do is something like since this shared connection also has to go to the source of this transistor, we're probably going to want to maybe flip these transistors around and bend this transistor down here like this and have a common VDD connection kind of in the middle, and then have a little jumper over between what would be the drain of this transistor, this D transistor, and this intermediate node between these two transistors. I think that's probably going to be the most expedient thing to do. Okay, so we're going to move the clock transistor. And we can obviously do a parallel thing with this one once we get it kind of figured out. So now we're going to do a little bit of surgery here. So we're going to make this the clock PMOS. So that feeds right up there. And then this is still sharing the common drain connection there. but we're going to do something a little bit different here. So I'm going to move this up a little bit so we have a little bit of room. And so what we're going to do is we're going to make this intermediate node the VDD tie. Like that. And then we're going to maybe have a little jumper that goes over here like this. Like that. And of course we have our corresponding D-bar transistor up here, and there'll be another clock transistor here. It's going to replace this transistor. So we have this PMOS, and I'm running to my jumper. Actually, I'm going to move this down a little bit. All right, so there's my little jumper. And I'm going to leave a little void in there. There's my clock line. Like so. Here's my D-bar transistor. To do that. And now we have our VDD tie. And so I'm going to make another little place for that to go. And there's our VDD tie right there. Okay. So I'm kind of liking that. I'm liking the fact that the clock transistors are all vertically aligned here, and all the D transistors are vertically aligned here. And now we have to think about kind of how to unfold this section, which is the bistable element here at the core. Okay. Well, what are we going to do about that? Well, here we have this transistor is tied up here. Right, and if we rotate that like that, we can rotate this like that, and we'll have to make a connection from there over to there. Right? But then the source of this transistor, we could imagine doing a similar thing with this pair of transistors, and we would have the source of these two transistors lined up, and we can make a ground connection over on the right-hand edge of the cell, which is really pretty interesting. Okay, so let's see what that looks like with this pair. So their gates are tied together. here the Nmos transistor, like so. And these gates were tied together. And the drains were tied together. So this is the drain of the Nmos. And has to cross over and tie into the drain of the PMOS. Okay, and this is going to get tied to ground over here, but I want to wait to do that until I get this guy tied in there too. Okay, and this drain connection is the gate connection here. Right? So let's do a similar thing. Let's move this Nmos transistor that's down here. And these two are tied to ground. Like that. And let's get this PMOS transistor up here. So I know the drain was tied to the gate of this one, and this one has to be tied to the gate of this one. And I know that this point here has to be tied to the gate of these two, and it has to be tied to this up here. And so this is a little funky, but we're going to have to somehow cross that over there, like that, and cross this over here like that. Okay, so I'd probably like to space this bottom row out a little bit. So I'm going to work on that. Okay. And I don't like that so much. So this one, go like that. Okay. So this is the pair of cross-coupled inverters. Okay, and it's got some crossing over. And so the two outputs are available here and here. Okay, now all that remains is to figure out which one was Q and which one was Q bar. And see. The one that D pulls down on should be Q bar. So it means this is Q bar and this is Q. So D is pulling down on this one, and tracing that up, that becomes this. Okay? So you'll notice that this is actually looking pretty nice, because we have now we have 2 rows of P diffusion and 2 rows of N diffusion. That's fine. But the transistors are all kind of aligned in columns that allow us to share the poly gates, and we have like little local connections here between a gate and maybe a neighboring source drain diffusion. The clock transistors are all sort of in the same column. The D inputs are all in the same column, and the cross-coupled inverters are all in the same column. So that's actually a really nice arrangement. Notice also, if we wanted to have something like the Q outputs available up above, like if we're having a shift register where we can shift bits in this way, but we want to have parallel outputs so that Q and Q bar are available to read out that way. That's pretty trivial because we have here Q. So we could run Q up this way, and Q bar is available here. Okay, so that's actually pretty nice. Now, we need to think about maybe the upside down version of this. It's fairly simple to do. We basically need to take this and flip it up to here, and this and flip it down to here. Okay? And so this is the phi latch. The phi bar latch might look something like, let's see, so we have here, let's take these up to PMOS up here. So move over here a little bit. Maybe do this one in a different color. So here we have and these are going to be tied up to VDD. All right, so these are these 2 transistors that correspond to these 2. And so this ground connection turns into a VDD connection. These Nmos's turn into PMOS's. And now, let's see, we have these 2 transistors, 2 clock transistors. Like so. Then we're going to have 2 PMOS transistors for the cross-coupled inverters. And those would be both facing, let's say, the same direction here. And this ground connection here will turn into a VDD tie up here. Like so. And let's see, we have a connection running from this gate there, and we have one running from see, this one goes over here and jumps over that one and comes out the gate there. And so that's the PMOS section that corresponds to this part down here. Okay. So then we have to do this part, which is going to turn into an Nmos part. And let's see, we have two Nmos transistors like this. I guess I want that one oriented down. And this one I want oriented down. So these are the clock. There's D bar. And now this is going to be a little interesting. This is maybe a little too tall. We have to jumper this one over here, this one over here. And maybe leave a little space in there for my ground ties. All right, so this section here corresponds to this section up here. And then we have our two Nmos transistors to finish off the cross-coupled inverter. And so this one is going to do something like this. This would be Q bar. And so this is the Phi latch. And this is the Phi bar latch. And we can imagine, bringing the interface here so that the Q and Q bar go to the right places here. So for instance, see Q goes to D. Right, so Q goes to D. Could basically get that here. Well, you have to work out the interfaces, but those are the two latches. One is the upside down version of the other. And one of the nice things about the pair of them is that even though this may have to take more space horizontally than this does, because for instance we need space for contacts in here, whereas we don't need space for contacts in here, there's a corresponding narrower piece here than down here. So the width of this piece in the phi bar latch should correspond to the width of this piece in the phi latch, and the width of this piece should correspond precisely to the width of this piece. And so these two as a unit will fit very nicely in a very nice uniform pitch with with no unused space. And so if we want to make a rising edge triggered flip-flop, we would put the phi bar latch first and then the phi latch. If we want to make a falling edge triggered flip-flop, we put the phi latch first and then the phi bar latch. Okay? So I mean that's the process that I wanted to go through. I haven't laid this out in the Skywater technology. Maybe I will attempt to do that so I can show you the layout. It may not be so instructive for me to actually do the layout in real time and record it, but maybe I could do that and speed it up so that in case you're falling asleep or having trouble falling asleep, you can watch it and fall asleep. Anyway, that's it for now. Thanks for watching.